My name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the GRE Official Guide, the 4th edition, 2025. If you do not own this book already, purchase one immediately. You're going to need it. Today is our lesson number 30. And we are on page number 228. Problem, as you can see there, is already on the blackboard. Is the second problem that appears on the page, problem number 2. Here's what the problem says. We are given a frequency distribution. Two distributions as a matter of fact, list X and list Y. Here is the list X. We are told that number 1, 2, 3, 4, 5 appears. These are the frequency. It appears so many times. 1 appears 10 times, 2 appears 20 times, 3 appears 18 times, 5 appears 12 times, so on and so forth. In list Y, we are told the observations 6, 7, 8 and 9. 6 appears 24 times, 7 appears 17 times, 8 appears 10 times, 9 appears 9 times. That is the frequency distribution we are given. The question is very simple, very straightforward. We are to compare the combined average. If you were to combine these two, we are asked to combine this list with that list and produce one list. And the question is, once we produce one list by combining the two lists together, then the question is, how does the combined average compare to the combined median? That's all it is. Go ahead, do it yourself. I'll give you a second to be able to pause and unpause the video, and then we'll do it together. Let's see what we can do. Because we need the room, I'm going to have to erase something. So let's first take care of this thing. The average of this list X is 2.7. Let's put it up there so we don't lose it. And the average of this list is 7.1. Let's put it up there so we can erase this part. And remember, in column A we have a combined average, in column B we have the combined median. Very simple. Very simple to remember. Well, first thing you should notice is, first thing we have to ascertain, first thing we have to establish, first thing we have to figure out is, do these two lists have the same number of observations? Because if they do, it will make our life very simple. Let's take a look at how many observations we have in list X, and let's see how many observations we have in list Y. And keep your fingers crossed. Well, I see 10, 20, that's 30, and 18 and 20, that's 30. We have 60 observations in list X. Here I see 24. Why don't we, instead of 7, I'm going to take away 1. That makes it 16. 16 and 24, that's 40. And if you take away 1, you're going to have to add 1 here, because I took 1 away from there. So that's 10 and 20, that's 20. But there you go. They both have 60 observations. Since the number of observations are equal, since the number of observations in the two lists are equal, therefore the combined average is going to be the average of the two averages. That's what we have to understand here. We'll first do the work, and then we'll prove this statement in a second. We'll prove this statement in 1 second. Let's first do it. So because the number of observations is the same, 60 and 60, the combined average is simply the average of the two averages. 2.7 plus 7.1. There are two averages, so we divide by 2. We get 9.8. 9.8 divided by 2. It looks like little under 5. The combined average is just a little under 5. Now let's prove why that is the case. Let's prove why the combined average is simply the average of the two averages, like we did here. We take the average of the two averages. Let's prove why that is true. You see, ordinarily, if you wanted to find the average of something, you would add up everything that you have there and divide by the number of observations. Here, since the average is already given, 2.7 times 60 would be the sum of all of these observations. In other words, we have 1 10 times, 2 20 times, 3 18 times. If you were to add them all up and divide by 60, you will get 2.7. So 60 times 2.7 represents the sum of all the observations. Similarly here, we have 7.1 is the average, and we have 60 observation. Therefore 60 times 7.1, that represents the sum of all the observation here. And we have a total of 120 observations, 60 here and 60 here. Let's see what happens. 120 observation. As you can clearly see, we have a 60 here, we have a 60 here. If you were to take away the 60 common, if you were to take 60 commons, we are left with 2.7 plus 7.1 over 2 times 60, and 60 drops out, and we are left with exactly what we have here, which is exactly why the combined average is simply the average of the two averages, because they have the same number of observations. Had the number of observations not been the same, had they been different, it would have made our life miserable. But they will not do that, because obviously they are realistic. They know that we have a very limited amount of time to solve the problem. They will not give you something complicated, something nasty, something horrible like that. Let's look at the median. So average is very straightforward. The average is something under 5. So the column A is just something under 5. If you need the exact value, we'll worry about the exact value. For the time being, that's good enough, just leave it alone. Column B, we're looking for median. And median, since there are 60 observations here and there are 60 observations here, median is simply the average of the 60th observation plus the 61st observation, and we take the average of the two. 60th observation is the last observation in this list, which is 5. There are 12 of them. There are 12 5s. 60th observation is a 5. And the 61st observation here is a 6, because we have 24 of those. We have 24 of those. The 61st observation is 6. Divided by 2, and you will see that it is 5.5. It does not matter what this figure was. It's something less than 5. Here we have 5.5. 5.5, of course, is bigger. Therefore, the median of the combined list is greater than the average of the combined list. I'll see you tomorrow, okay? Bye now.